Hello and welcome to Chaos and Caffeine, where we try out different coffees. It could be anywhere from the weird, expensive stuff all the way to what we're going to cover today, which is I'm trying out a machine at 7-Eleven that does some of the foofy drinks. So I've tried a couple of the other ones. I have not tried their cappuccino yet through the foofy machine. That's my official name for anything that has anything other than black coffee in it. So this is going to be a hazelnut cappuccino. We will try that in a few minutes, and we'll see how it goes, because, you know. In any case, the other thing we're going to cover today is it was Standards Week. Outside of the fact that in addition this week it was Halloween yesterday, and I, of course, had planned for a costume party. A customer said, "You really want you to dress up this year." So I had the black Tahoe and I had my Oakleys, and I went ahead and finished out the costume, and I was told it was too scary. So basically I won the costume contest and because I was too scary, and I wasn't allowed to wear it. Oh well. In any case, yeah, we'll have fun with that at another time. So I'll let your imaginations ride. But I was having a little fun, with the whole concept of the 51st state and a couple other things. But neither here nor there. So we are then going to get into, for me it was Standards Week. Most of this week was dealing with standards meetings. People were contacting me, wanting me, oh, can you do this and that? No. These are way too important right now. A lot happening in industry. So I had standards, and then I also had the IEEE Grid Code Committee, which was also very, very important. I'll discuss some of that. And then I'll go over a couple of things on some of what I'm working on and why these standards are so important. So let's start first with, because I need some caffeine. I don't think I'm going to get a lot out of this, so I got a large to top it off. So this is the cappuccino, the hazelnut. I'm going to swirl around a bit because I watched it fill almost all the way up with foamy milk, and then they toss a little bit of basically, I don't know what the strength is. So I have my backup coffee with me, which is Death Wish. Which we know has 650 milligrams. So this is more going to be kind of, like I said, my dessert drink in the morning the day after Halloween. If it gets really bad, I can always kick in a 5-hour energy, get the one with 260 milligrams. But neither here nor there. So let's go ahead and see. I got the hazelnut flavor. Figured might as well flavor it so I don't just get, bleh. So let's see. Biggest worry I have is that, as I mentioned before, I'm going to stir it up a little bit, is that chemical taste I got out of some of that pumpkin spice stuff last week from the one I expected to. So let's... all right, not too bad. Suppose there's hazelnut in there somewhere. Oh, there it is. Yeah, not overbearing. I can only imagine that the regular cappuccino would have been nearly tasteless. But would I do that again? Nah, I'm not in for that kind of drink in any case. I'll do a cappuccino once in a while. When I'm in a restaurant and it fits as part of a dessert drink. Yeah, you'll watch me finishing that off first before I start into the other. Luckily, it's early enough, so neither here nor there. So big things going on in the insulation world. I'm working on an article I'm going to get out to Reliable Magazine that is, I don't know what they'll end up titling it, because the one I just put up there was supposed to say a fairy tale, and they didn't do that. It had to do with, AI, of course. But this one, first draft, from base load to cycling, how changing power generation trends increases thermal plant start-stop cycles, what the impacts are, which was a big part of our grid code discussion. And the grid code discussion is here. This is the draft for the one the team is working on. In a lot of this, I am the only person representing. So instead of, because we do everything, we're involved in large synchronous generation, even coal-fired plants. Little bit of supporting stuff in the nuclear stuff. I've done a lot of reactor coolant pumps and during my time. Excuse me. Excitation systems. I've been involved as an expert witness in nuclear. Pipelines, you name it, we're involved in it. The focus everybody seems to have me on or expecting of me is because of the vast amount of work we've been doing in whether you call it clean energy or whatever else. Now, I'm going to give some quick definitions because some of the articles I put out last year referred to utility scale solar and wind and energy storage as distributed energy. And the idea was distributed energy is basically a whole lot of stuff. Well, what they started calling distributed energy when it comes to wind, solar, and energy storage is IBR, or inverter-based resources, because there's variable frequency drives involved. Which reminds me, I'll cover one more subject on standards that I'm doing for American Clean Power, which affects, by the way, IEEE, IEC, and CIGRE, because we have the data that they don't have from the wind, solar, and energy storage, or IBR community. So I'll cover a bit of that when we go through this. I know it's not going to sound real exciting, but this stuff is going to impact all y'all. So, in addition to the standards I'm going to cover, which are specifically for electric machines, I'm involved in the standards having to do with wireless systems, so all the wireless vibration stuff and everything else. And I'll be quite blunt. The people that are in the industry selling wireless vibration and all that other stuff, I don't see them at these meetings. So we're literally writing the standards they're going to have to follow. And, while I have no issue with wireless systems, I was involved many years ago, and I know some of the issues that were there in industrial applications. The other thing that we're having to deal with is a lot of the stuff with artificial intelligence and the impact it's having on the new generation coming into industry. And that is shaping how we're dealing with standards now. Big part of that has to do with the fact that we have to add educational bits into these standards. And this goes back to education. I have not been able to find newly graduated electrical engineers that my company could bring on board. We're not large enough for me to sit there and have people off of billable work to teach somebody how to use a multimeter, what a resistor is, things like that. It's horrendous. It's the state of education these days, and it's not just the U.S. Sorry, folks. If you're in academia, get your fucking head back in line and start putting out good quality education in the electrical side, because what we're getting is absolute garbage. And that really, really bothers me. I mean, when I figure that my guy who my intern that I have that is learning from me electrical and current signature analysis, in addition to doing some other stuff that I thought I would have an electrical engineer do, knows more than the average electrical engineer, and he hasn't even graduated as a mechanical engineer yet. Or when I go into the wind industry, and the handful of electrical engineers have been in the industry for a while and have already learned everybody else is mechanical, which is why some of our research is so important, because mechanical guys are looking for mechanical solutions to electrical problems. So, I had one academic And how did my intern go? You don't like academics, do you? I said, I'm just disappointed. I sit there and I'm going to calm down just a little bit. I don't mean to get on these and rant, but just, there's so much going on in the industry that shouldn't be. So, in any case, in our group, in the IEEE, in the standards group in materials standards, we have a very small. There was, at one point, we had over 70 on the calls. All of them were my age or older, with maybe one or two exceptions when they were able to break away and come on the call. Maybe 10 years younger, 15 maybe, tops. I'm one other person who's younger than that. Hopefully we're going to watch people like that come up quickly. He's chairing a lot of stuff. He's doing a lot of good work. That's Chris Stroud from Electrical Motor and Contracting. But when I look through the list of people involved, it's OEMs, handful of end users, instrument folks like myself, field service guys like myself, motor repair, that's him basically, myself. No low voltage guys other than myself and where is he? Dave McKinnon from PDMA. So yeah, PDMA is involved, Megger's involved, we're involved. Nobody else is involved in the low voltage side of the industry. So anyways, let's go through what some of these are and why, and I'll get into why this is important. So, I'll do that first. So I will be starting, because we're allowing the original PAR, which is this one here. Actually, it's just the first 2 pages. I got the whole original standard attached, so it's not this. 1415, which I was involved with, was called the IEEE Guide for Induction Machinery Maintenance, Testing, and Failure Analysis when we published it in 2006. It became a dumping ground for commercial stuff. So I was chair of it again in 2018 briefly, and then it was taken over by first a Japanese academic and then a Chinese academic we've never been able to find. He was named on the last PAR, and then it was allowed to die. It was supposed to be reworked, so that was 2019. The expiration date is this December. I would have been limited to 1 year, 2 at the most, to try to do something with this standard, which actually requires a full rewrite. Okay, so going back and eliminating what I know went wrong originally, so we're gathering the team together. This will fall under the IEEE Power Engineering Society's Motors Group, although some of the meetings I'll have with the materials subgroup, because the materials subgroup is doing all of the component testing that would be used in failure analysis. Cover that in a minute. It's also going to give us a chance to do things that I've been fighting for ages, like finally getting a standard for an assembled machine for surge testing. There is no such thing for field surge testing right now in any part of it, with the exception of offline PD, repetitive PD testing. That's meant for surge testing, but we need something for this. So this was limited to form coils. So I'll start with this one. It's because we don't put the IEEE in front. Now it's the Guide for Induction Machinery Maintenance, Testing, and Failure Analysis. Now what's important is a guide is not a recommended practice and not a standard, meaning that it's there to provide a process, but there's no requirement for it. It's not something somebody is going to take this and say it's a legal document. However, if I were to walk into a situation where I was an expert witness, this is what I would want to have. I'd say I'm deferring to my work in this area. It is going to include some technologies that have not traditionally been in some of the other standards, et cetera, et cetera, et cetera, but they have to have peer-reviewed work behind them. So what happened in this one is it became a dumping ground for everybody's technology, for marketing purposes, wanting to be involved in the standard. So I wanted, at the time, I wanted to make sure low voltage testing was involved. That was countered by the high voltage testing, the surge test guys, by suggesting that things got broken up. So it became absolute junk from that standpoint. Then the big part that should have been in there, because the first, where do we go? Like 30 odd pages of only about almost 60. Is it 60? 58 pages, including the cover, being testing stuff. And then the actual how to perform a root cause analysis on an induction machine was relegated to a single chart and just a list of failures, which is garbage. And that was the intent, was because commercial technology, here, this is the only chart we have in the whole thing for how to troubleshoot an induction machine. It's complete garbage. It does nothing for us. If I look, EPRI had done a set of charts. I mean, it is a book that's 67 pages thick that has all charts and how to troubleshoot each different type of problem. That's what we need to include as a standard or something along those lines. So our process and procedure will probably be a little different than that one. We will absolutely be referring to it. IEC has different standards for RCFA. We'll defer to that as well, but it doesn't do anything specific for machines. Now, what's particularly important in this one is it is a maintenance testing and failure analysis guide for form wound, not random wound, squirrel cage induction machinery rated up to 15 kV. Addresses stator winding, rotor winding, and core. That could be a form winding or a wound rotor. That's important to understand, because what I did do is, for my own reasons, in the new PAR, I included wind turbines. So that would be defig and induction wind turbines. For those that are in that community that are listening to this, that means we will have an IEEE guide for how to do the troubleshooting, because believe me, I'm fully aware of some of the companies out there that are trying to sell their little toys that don't know how to troubleshoot a wind turbine, and they've been lying to people. So it's going to include all the tools and technologies necessary, because we still have to include that. My intention as the chair of this standard is to suggest, because they're collaborative standards, I don't get to outright say, but I suspect my responsibility is going to be probably the greater share in writing some of this thing, plus contributions from all of the other members, which I haven't made a call out for people. I'm going to start that in December. I have had people already volunteer. There are standards that are listed in here that no longer exist. By the way, if you want to contribute, you don't have to be a member, because it is an ANSI standard. I believe we're ANSI. Yeah, because they are basically follow the ANSI process. Any ANSI type standard, even if you're not a member of an organization, you can participate. You don't get to necessarily vote, and you don't get to do anything outside of public comments, but and you won't get listed in there. You have to be part of IEEE SA for that, or Standards Authority, such as I've been since, I think, 1993. So that would be well over 30 years. And nah, I'm not that old. Couldn't possibly be that old. In any case, so this one covers a couple of things. Let me read the original, because all we did was modify the original purpose a little bit. It is going to provide guidance concerning the appropriateness of various maintenance tests and interpreting the results of those tests with respect to failure analysis and to routine predictive maintenance activity. This is going to be a condition-based maintenance standard. And yes, it doesn't just cover the electrical stuff. It will cover vibration analysis, ultrasound, and the other technologies. So we'll finally have a standard, especially seeing as people are throwing around condition-based maintenance and ideas and why they're doing it and all the marketing bullshit and foo-foo crap and everything else. We're going to get down to brass tacks. This is going to be a common sense approach. Because it's IEEE versus IEC, IEC allows domination by OEMs and stuff like that. So all the instrument guys can run there and dominate the standard and basically say, you must use our product. Or what I'm also seeing is a couple of professional and trade organizations being inundated with people that say, oh, we need a document that says what predictive and condition-based maintenance tests to do. We want to sit on that and we want to dominate it and say anybody who does not fit in our view or our product line, we're going to exclude them. Or we're going to tell bullshit stories about them, such as what's happened to electrical and current signature analysis in a couple of the organizations where these technical committees have gotten together and created guides on what technologies to use for your thing, and they're completely dominated by people in those technologies. So, placing a vibration sensor on a wall in another room should be able to detect your early bearing fault. Or AI-based systems should be able to do everything. You don't need people. That's out the window. This is consensus. It's there's a whole lot of rules you have to follow in a standard versus just putting together what I'll refer to as marketing sales bullshit guides. I've read some of them. I absolutely object to them. I attempted to object to them to those organizations, having been blocked from sitting on their technical committees because I don't necessarily agree with the other folks. So, oh well. I'd rather work with the real people who make the real standards in any case instead of the marketing folks, because that's pretty much what they're dominated by, marketing people who have no idea what their technologies are capable or incapable of. That's also, by the way, why we pulled out of basically all of the commercial conferences next year, coming up in 2026, because I'll be blunt, my feeling from all of them, and I think it was reinforced when my intern came out and he goes, what am I learning from this other than feeling like I'm being sold a timeshare? And so most of them, I started paying attention to that after hearing that comment, going, why am I spending money putting in a booth? Why am I sponsoring and why am I doing this other stuff when all I'm doing is pushing timeshares for some of these marketing-based organizations? Okay, off my soapbox. So this one here, it's going to be specific to the machine, not the driven equipment. Some of the technologies will say also ... but it will be appropriateness, what they're able to detect, what you should expect to see. I don't know how detailed we'll get into troubleshooting, et cetera, because lawyers are now involved, so they want to be very cautious about, if you say this, we could be sued. We just had that discussion. But, things like bearing insulation stuff, testing that, core loss testing, capacitance, vibration, dissipation factor, inrush current, current signature analysis, voltage signature analysis, insulation resistance testing, partial discharge, phase balance, which, was left really, really, really foofy. Except I had tossed in 5% impedance and 10% inductive unbalance as kind of a suggestion. Surge testing, surge PD, which was starting to be a thing then, thermography, shaft currents, vibration analysis, including a chart, ultrasound, torsional analysis, things like that. So there's a few others in there. That dominates the first part, and then of course charts as to when they use them and what type of data you have. Also information on how to preserve data. The RCFA process in here was basically a checklist. So what you want to do is just go through, and when you're troubleshooting a motor, just run the checklist, and that gives you a root cause. No, it doesn't. You know that, I know that, so that's what's going to change. So, getting back to what we did this week, because I haven't been able to start on this yet. Our first meeting will probably be January, February, just kind of like my other meeting that I'm supposed to be responsible for. Haven't kicked off that meeting yet. I'll explain why after I cover this stuff. So this week, the materials subcommittee. Now, we have a lot more standards than the ones I'm going to mention, but the ones we worked on in order were P, which means that it's in development. Okay, so P means there's a par out on it, and it's either being rewritten or it's in development. So P3149, which will end up being IEEE 3149, the guide for dissection techniques. That basically means how do we remove and start cutting into the windings in order to identify different types of problems, from aging to defect to whatever, so that we are all on the common page, meaning the OEM, the end user, repair shop. I've been guarding the repair shop. Some of the OEMs have suggested that nobody but an OEM should be doing dissection. I would have a problem with that because I've been an expert witness against some OEMs, or defending users against some OEMs in which I had to perform dissection. I'm not going to rely upon the people that I'm up against, their experts, to do my work for me. That now means that we have different dissection things and everything else. We've contributed a number of results from what we're doing with form wound machines. So again, it primarily relates to form wound machine. You'll hear that as a constant through here. Random wound machines have almost been thrown out the window because there's not enough people on there. So the next one is 1434, which is the guide to measurement of partial discharges in rotating machinery. It is the guide for partial discharge. So that is being improved and updated. 117, which it was kind of a discovery meeting. 117 is the standard test procedure for thermal evaluation of systems of insulating materials for random wound AC electric machinery. This one here was basically being allowed to basically retire. So the question that came up was, do we want to revise this? That would be taking things like motorettes like this one and doing aging tests. Very, very important for hybrid and electric vehicles for reliability purposes. IEC has a few things that are similar. The difference, as I mentioned before, is the IEC is dominated primarily by OEMs, whereas end users, the percentage of people have to be end users, consultants, and other type of expertise in IEEE. There's a specific mix requirement. Next one, and this was from Tuesday, 1776. I always remember that one. Recommended practice for thermal evaluation of unsealed or sealed insulation systems for AC electric machinery employing form-wound pre-insulated stator coils for machines rated 15,000 volts and below. So that basically means form-wound coils for large machines. And these would be primarily B stage, not VPI'd. The next one, which is a really important one, this one is 62.2, which we're about to vote on. I think we just went through comments again. And the author, or the chair, will know what I mean when I say ratios, really, should, coulds, will, won'ts, all had to be ratioed. Never heard of that before. So we had to have so many shells and so many shoulds, da 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 da. So guide for diagnostic field testing of electric power apparatus, electric machines. So that falls under the material subgroup as well. The other one, the one that I'm chairing, is actually under the motors subgroup for the EMC or electric machinery group. So 62.2, that one's almost out. That one's been around for a long time. There is no 62.1, which used to be transformers. 1510, or is that, 1310, I'm sorry. Recommended practice for thermal cycle testing of form-wound stator bars and coils for large rotating machines. This was a big discussion because we're seeing a lot of thermal cycling stuff, and that's part of that article that I was talking about where, and it actually came up in what we were talking about in grid code, which means what's the impact of thermal cycling. Now, what I got back from the OEMs is it not as big a deal as people thought. What I got from grid code is the exact opposite. So how we balance that, not quite sure. Grid code is very, very important because that's how you operate the grid. Grid hasn't changed. It's still the same way as it's been since the 1910s. So, over 100 years, and of course we don't operate it the same way, but we're still sticking to the same principles. That's a whole other story. IEEE 56, which is the guide for installation, maintenance of electric machines, which is inspections and everything else. That's on the way as an update. 1719, or the guide for evaluating stator cores of AC electric machines rated over 1 megawatt and higher. Primary focus has been on hydro machines, although we did get some pushback on a couple of things in there from turbo machines. That's your two-pole steam and related machines versus hydro, which are slow speed. 1043, recommended practice for voltage endurance testing of form-wound bars and coils. Now that's an important one for the reliability of the machine. So combination, we look at thermal cycling, stator cores, and the other, that's basically the winding package for most of our power generation. Some of it affects standard rotating machines, etc. Now we've already been into Wednesday, so getting into after lunch, I got to do the next part, then I had to leave. So I can only, I haven't seen the notes yet on the other two, but I'll mention what they are. So after lunch, I sat in P97, and I had a doctor's appointment, so I was late for a reason. P97 is the diagnostic test methods for AC electric machinery using direct voltage. This is the one we're looking at insulation resistance profile and winding insulation resistance, charging and discharging methods, as well as a few others, but those are the primary ones. So, how to look at your insulation resistance profile in order to determine the condition of the equipment. Now, what's particularly interesting is I've seen a lot of absolute garbage showing up on places like LinkedIn where people have gone, and it's very obviously AI-generated material, and they'll throw it in there like how an insulation resistance test is performed. And I read through it and I went, that is totally wrong. You're going to get somebody killed. And I'm waiting for somebody to be held responsible for the crap they're putting up there. There is no standard. They even suggested in one insulation resistance limits, Megger limits, for whether a winding is good or bad. There is no standard for that. None. I'm sorry. 10 megohms, is that good or bad? And then they'll say, well, according to standard 43. Now, I'm sorry, standard IEEE 43 basically says that if you pass these values, you can go on to the high voltage proof testing. It has nothing to do with whether or not it's going to pass or fail. If I'm in the military, it's 1 megohm. 1 megohm, they decided that 1 megohm above is good, below is bad. That's it. That's it. It's not good or bad, pass, fail, or whatever. That's a value used to determine if you should be able to, without potentially damaging the winding, perform your high voltage tests. So P97 gets into how to interpret other things like the insulation curve, which has to do with how the insulation system is reacting to being good, dry and brittle, contamination, things like that. So you want to, when that comes out, it's a brand new standard, didn't exist before. Well, P97 was a standard before. This, completely different. A lot of work's gone into that. Helene I'm sorry, I'm going to pronounce her name wrong, and I've known her forever. Helene from Hydro-Quebec is the lead on that. Doug Conley from Siemens is also involved, as well as some others. Myself and Dave McKinnon. Dave McKinnon's from PDMA. Have been doing a lot of the contribution for the insulation resistance profile. Sorry, I cut myself shaving today. So next one, 2 I missed. 95 is back up. That's basically the recommended practice for insulation testing of large AC machinery with direct voltage. That sounds similar to the other one, except the other one is diagnostic test methods. This one is recommended practice. This one is your high potential test. That will not be in the DC, the test methods. That's in recommended practice, because that's a method that's been around since, the Dark Ages or the Stone Age, when we built motors out of stone, carved them out of stone, haha. And then finally the IEEE 43, probably the best known standard, the IEEE recommended practice for insulation, for testing insulation resistance of electric machinery. Now, what's going on here has been very exciting, because back in 2000, there was the attempt to do certain things with it. 2013, there was the attempt to remove insulation resistance testing from random wound machines at all, including polarization index. We fought to keep it in there, because it's like, okay, well, what do we do then? Does that mean we don't test? Oh, no, you don't need to test random machines. Trust the OEMs. Well, the reason for that happened to be, and I was involved in some of the tests because I was working for a company at the time, and they were coming in, and we were testing brand new electric motors. They had transferred the manufacturing, at one time primarily Mexico, and then over to China, and at this point it had moved to Vietnam. And we could literally pour the stuff out because they were using the wrong thinners for the materials, and they couldn't pass a simple insulation resistance test to allow us to do the high voltage testing, because the windings had never properly cured. So, of course, the OEMs involved were all up in arms, and they were given the direction to, remove it. Don't correct your process. Remove the test. Oh, no. The end user can always add that to the specification. My response to that one was, that's not how it works, because what'll happen is I will tell my customer, you need to do an insulation resistance test, and then you'll bounce back saying it's not in standards or it was removed to standards, therefore we were refusing to do it. I've had that happen to me before, and then I've had to go in and troubleshoot the absolute garbage that's been delivered to the customer. And when the customer turns around and says to the OEM, hey, warranty, they go, well, you didn't ask for it. So I don't trust OEMs. So basically, there's standards there for a reason. We got that back in. What did get removed, against everybody's objection, especially mine, is insulation resistance of edge-wound rotors. Because of the insulation material, Well, guess what? Army Corps of Engineers has stepped back in, and they have a little more authority than little old me. So they go, no, we do that test. And yes, we've had problems because of exactly what I just mentioned. So we're demanding insulation resistance testing of edge wound machines is returned to it. Now, I wanted to be part of that fight because I like a good once in a while. And by the way, these standards are fun to do that. We still refer to my poor intern Amar when he went with us to this group over the summer, because there's a lot of work that happens in between the meetings. We have 2 meetings, one in the summer at Electrical Installation Conference and one usually in the fall. And he walked in and it was terrible because the Canadians were objecting to coming down to the U.S. because they didn't like being the 51st state, and et cetera, et cetera, et cetera. And some of them were not allowed to travel to the U.S. for political reasons and yada, yada, yada. Then again, that's why I decided not to go to... No, I'm just kidding. So in any case, but those were the real reasons. So about half of our group was on a big screen in a large room, and we were spread throughout the room. So Amar goes, "Oh my God, this is terrible. It's horrible." 2 days of basically them talking online and us not able to hear it, and vice versa, and having to do. And I referred to that to him, and I said, "Oh yeah, we're going to do a standards meeting," and he freaked out, and I said, "Oh, yep, standards PTSD." So that'll be in the image in the beginning, I think. He'll think that's funny, I hope. But in any case, then finally at the end of the day, but my appointment went long, not because there was any issues, just the doctor was running a little behind, so was there a little too long. So in any case, the material subcommittee meeting, which is the group that goes in and says yay, nay, and everybody reports out. So everybody that was involved also sits on that. There's a good group of us, somewhere 70-some of us in this group, all material specialists. So when people come in and, "Do you know anything about that?" "Oh, of course I do. I sit on the standards groups." Like I said, I've had people listed in those things. I've been pushing back on some of that because I had one of the groups, one of the trade associations come out, make some statements about some standard, and their guy who happened to be listed the standard, but I'd never seen him in a meeting and I hadn't missed one, and I was on that standard, say some horrible things about the standard and that weren't accurate at all. So I pushed back, and now I'm saying if that person is not attending, they should not be on there. It should not be politically motivated to have somebody sitting on a standard. Otherwise, bad information is getting out, and it's getting out to the wrong people. It's getting out to the people who have to use the standard. So in any case, going back to this, so that's that. That all will end up tying into my work here, which we also did not do, because this is actually in the motors group, which is separate from this group. There's usually no tie over. I was going to ask, so this is wishful thinking for me right now until I get an okay. I want to have at least one of my meetings for this with the materials subcommittee so that people involved in those standards can have input on how the standards are being used in this. I want this to be a really, really, really important document. I think it's needed, especially with a lot of people coming into the industry and some of the stuff I've seen as far as people troubleshooting electric machines, which is absolutely horrific. Now, mind you, don't get me wrong, that's how we make our money. When those guys generate a disaster, we get called in. So our last day was on this. This is the report on coordination of grid codes and generator standards and the consequence of diverse grid code requirements on synchronous machines. The last version of this, November 2018. I didn't see some of the recommended stuff in there. I had only had a copy of this that I had printed out for my trip to Croatia when I was starting to work through my comments. I got those all in. And the introduction that had come out had basically said the recent energy transition towards large-scale integration of renewable energy sources into the electrical supply system to combat global CO2 emissions across the world is leading grid operators to specify more stringent operation. Oh my God, that's not the reason why people are using it. So I turned it into a bit of a history lesson. There's a section in here I'm doing a rewrite as a recommendation. I mean, basically what happens is if I want something different, I have to write it. You don't say that's wrong and walk away. You actually have to make a recommendation. So apparently another gentleman had put a paragraph together to replace that paragraph. And I put a longer paragraph together that actually went back to look at what had gone on before, the history portion of it. I don't know how this will be adopted or if it'll be adopted, but let me see if I can find it. So that was it. And I mean, basically, if I were reading this and you know, the original introduction, just the first page, and I were, you know, IEEE has taken a stance that you know, this stuff is necessary based upon global emissions and so on and so on and so on. Whether that's your thing or not doesn't matter. Either direction. There was the information that was present in here. So let's go to, I meant to have this open, but I did not. Or maybe I won't. Okay. I'm not gonna, oh, here it is. See if I cause problems for myself. Let's see, where is my modification? Here it is. So now I put a few others in there. First thing is I changed renewable energy sources to more reflect what's going on. Now again, my job here is not so much to, you know, I'm not I'll just say I don't try to position myself as a champion for any. Nobody else is attending these. I was told people were attending these when I was chair of ACP, and they're not. So what I changed it to is grid operations since deregulation efforts in the 1990s and the adoption of large-scale new generation systems such as inverter-based resources, IBR, and virtual power plants, which, by the way, includes like collective groups of distributed energy, which means like homeowners and small scale or you know, business scale local power that gets together and they provide power to the grid. That's a big definition, right? So there's, when you drive down the highway and you see all those wind turbines sitting there, whether they're turning or not, by the way, they're actually working. So those don't go local. If you live next door to one, you may not be getting the power from that. Those go to the grid, the bulk grid, and that bulk grid then distributes the energy outwards. So they contribute to maintaining the voltage level. So the more current you pull, the you know, the lower the voltage goes, and the less current you pull, the higher the voltage goes. So what you need to do is balance that out within a very strict limit. Into the electrical supply system in an effort to improve the efficiency of power delivery worldwide, allows grid operators to specify more stringent operation and flexibility requirements for generating equipment to safeguard the power grid operating integrity and reliability, where spinning reserves allowed for steady operation of large synchronous machines in a regulated environment, regional and national environment. So basically, in this I'm talking about as we transitioned in 1996. Now, what gives me a unique perspective on this is, as it turns out, in 1994 through 1996, I was IEEE's Midwest region, the 10 Midwestern states, representative for energy to IEEE USAB because nobody wanted to waste their time. I was a young kid in my 20s, very, very enthusiastic, and I said, yeah, I'll be part of that. So I got put on the committee, and so it just so happens to turn out that was the group that was advising back on deregulation. So we had certain concerns. And by the way, all of those concerns have occurred. Now, one of those concerns was that other generation methods were going to start coming in, and suddenly we're going to be varying load and reducing the reliability of the machines, which has an impact on resilience. Now, there was another paragraph that was added to this by another individual, and it turns out that both of them actually complemented each other. So his paragraph and my paragraph, which is much longer than what I just talked about, became very important. Now, let's see, down in the end, I said those responsible for designing generator and excitation systems are required to understand these variabilities and potential future operating conditions in order to meet owner life cycle expectations. And I wrote that there because when we did deregulation, what happened is there was a mass introduction of natural gas resources into the thing, that where it took several days to start up a nuclear power plant, and it took a day to start up a coal-fired plant, and those might start and stop with a fairly constant load a couple of times a year at most. Now, all of a sudden, they're starting and stop. Well, not the nuke. Nuke is always on, but coal-fired plants were being required to vary their loads pretty consistently. Well, nuclear could vary their load, but sometimes shut down and start up. And then the natural gas plants, those were able to start up within 30 minutes and come up to full power within 30 minutes. You push a button, you're online. Well, IBRs, those are instant. There's also other benefits to inverter-based resources, and that's wind, solar energy storage, and a couple other things, right? But those are the main ones, is that they have electronic response to things like data centers. So we did include data centers in one of the paragraphs as we went through. So I added some stuff through the rest of it. There was an additional paragraph that was modified in the introduction, et cetera, et cetera, et cetera. So now we're getting into the rest of it when I cover a couple of things. It looks like I might have to write a section on IBR, being the only person in the group that actually is involved in IBR. And then also 3.4, which goes into the impact, because there was a paper cited. We always have to cite papers, but in 3.4, I actually have a lot of documentation from NREL and other organizations. Yeah, I print stuff once in a while for that. So in any case, that was our big thing. What was discovered was what we were concerned about, because the Iberian Peninsula, or the Spanish outage, came up again, and it was, we need more voltage control. And I said, well, part of what came out in all the reports is that they weren't set up right to do voltage control. They were allowed to basically have a fixed voltage and frequency on the IBRs, which contributed to everything. So instead of using them for what they're capable of doing, so you might see a site down on a windy day. What they did is they curtailed it because they wanted to use base load power because of whatever the demand was on the industry. You can't really go out and comment on that kind of thing, because you don't know what the power usage is at that point in time. Okay. So there's reasons why they do things, and it has nothing to do with your personal feelings or who's been elected or anything else. It has to do with, yes, money is a big one, but other things that have to do with the stability of the grid. So also this week was an issue with the International Building Code, in which certain individuals there keep proposing that somehow they're trying to control the grid, and that makes no sense. They're supposed to be about safety and buildings not falling down on people. And these people want to demand that all power be back up within an hour, or some ridiculous thing. That was something else altogether. And then, of course, wanting structures used for IBRs basically to meet just not really basically to cost them out of existence. Because of their personal beliefs, I think. Well, based on what I'm seeing, when they admit that they don't know anything about the grid, but they're making demands on the grid. I'm sorry, if you're going to write a standard that impacts electrical production, that, by the way, would negatively impact electrical production, you probably want to know a little bit about it. Welcome to Standards Wars. So let's get into one more thing, and then I'll cover one last thing on top of it. So in the past, right up until 2019, there was no history on the gassing issues going on with IBRs. Now, those gassing issues have to do with harmonics right at the generator, not the harmonics they're putting on the grid. That is a completely different topic that we motordoc is directly involved in researching, in which we've discovered that it's not because it's all filtered out through the site, but what's happening is a lot of loads are putting high frequency harmonics back in the system that are affecting your bearings, for instance. So there's a lot going on in that part. That'll be another subject for another day. But in any case, the standards in IEEE and IEC in particular, and other standards, specifically excluded inverter-based resources for dissolved gas analysis, or DGA. Now, DGA is used to determine the overall condition of transformers, whether they have insulation breakdown, other conditions going on, arcing, etc. Now, there are other condition-based testing, but this is a method of taking an oil sample and seeing what's going on. So, two things. I stepped down as chair of American Clean Power for a couple of reasons, but one of those was because we didn't have enough people. There was a study done for American Clean Power by Doble that was published in 2019 on DGA of wind turbine style pad mount transformers, and that was specific fluids, et cetera, et cetera, et cetera. Then we are in the middle of one that's being done by EPRI for us that's involved in solar, and actually it'll be BESS as well, dissolved gases for natural esters and synthetic esters. So we have split those up. So this is the one I just got the draft, the review draft for the esters. We've already approved the other one that's going through the process now. I'm chairing that, and I'm the proposed chair for this one. So as soon as this one is complete, we're going to start the standards development of this one. So ACP is paid for an in-depth study of from the industry on what their DGA numbers look like, and what the actual findings are, et cetera, et cetera, et cetera. So we have the history that was used for standard distribution systems. We have the same thing. We're going to have ACP standards out, and those will contain enough information to allow the other standards bodies to pull in that information and make recommendations if they wish, or they could just defer to this. Doesn't matter. But that will be a global standard. ACP is a global standards body. It's ANSI as well. So it means that those standards are going to be available everywhere. Final item is the other thing that I am responsible for, which is in CIGRE. It was brought up, and I'm like, well, shoot, we need it. And everybody knows my background in electrical and current signature analysis. So I'm convener of working group A1.78, and I also happen to be the United States National Committee for CIGRE's A1 study group chair. But this one is titled Guide for the Application of Electrical and Current Signature Analysis of Electric Motors, Generators, and Powertrain, in which The intent is to get rid of that crap that started many years ago and was just pushed out by everybody, and I still keep hearing it, that somehow ESA and MCSA is limited to the rotor. Somebody even here, we had somebody put out something recently on LinkedIn that said MCSA is for rotor testing. Wrong. So if you're using it for rotor testing, you're wasting your money. I could use a clamp-on analog meter for that, but instead you're supposed to be using electrical and current signature analysis as a different form of vibration analysis. That's basically what it is. It just sees everything everywhere all at once. And if you got good resolution, it allows you to look at no load and compare it to full load conditions. All kinds of cool stuff. Is it perfect? No technology is perfect. But we've got our working group written down. I was hoping to get the responses from some. I was trying to get additional people on board through the big national meetings over the last several weeks. That didn't happen. So any of the people that responded are now in the committee, which luckily that means it's going to be a small, tight committee, international in scope, and we are going to cover all of it. That includes rules-based as well as, let's see, the scope shall focus a survey of ESA and MCSA technologies that are presently available and techniques being investigated within academia. So that's going to be all the way through basically everything. Few exclusion examples include, this is what we're going to leave out from this, automotive and related, machine tool and robotics, traction machines such as locomotive, transformer analysis, DC motors and drives. Part of the reason why is because that's our area of expertise, and personally, I have no intention of letting our IP out. That'll be handled separately. So everything else is power quality, electric machines, three-phase induction machines, squirrel cage and wound rotor, including wind generation. That's also ours, but we've got a lot of users worldwide, including almost every OEM. Synchronous machines, cylindrical, salient pole and permanent magnet, cross the line, electronic drive, or soft start. All types. Random and form winding of any power and voltage rating. So not just random wound, not just form wound. Mechanical conditions such as bearings, alignments, off-foot, loose or bent shaft. Electrical conditions such as winding defects, rotor defects, etc. So that's the motor itself, in the driven equipment, all the rest of the stuff. If you followed any of the peer-reviewed IEEE and other papers I published this year, because nobody else has published anything along the lines of driven equipment and why you can see it. I've got that. I've got the winding stuff. I've got a bunch of other things that are multi-year research studies, decades long in a few cases, that are now published in peer-reviewed. Because again, I am not going to allow commercial marketing material to be used. So if somebody approaches us and says, oh yeah, I got this blog post I put on my website that says we are the gods of electrical and current signature analysis, that will get thrown out the freaking window. We will not accept that, plain and simple. It's going to be peer-reviewed, engineering-based papers, not something that was written in a commercial magazine or anything that smacks of basically marketing materials being presented as if it were fact. Because I watched too much of that crap, including keynote garbage, in some of these conferences this year. It disgusted me so much. The conferences I've been associated for decades, I will never, ever attend again. So it just disgusted me when they went completely for the commercial thing. Forget it. Done. I'm about truth and dealing with the customers in honest discussions and capabilities, because we're seeing this stuff being applied in the field. We're correcting this stuff being applied in the field all the time. And it's damaging the industry. You guys are killing the condition-based maintenance industry. So, fuck you. And that's it. So if you want to know my opinion, that's what I'm pissed off about. I've spent 40-odd years in the industry, and I'm all about new technology. We're adopting and we're doing new technology. But when I got marketing people because they receive, oh, we got an investment of this many tens of millions of dollars, so we're going to create a new idea that we stole from everybody else, use exaggerated, impossible numbers so that we destroy any credibility of the real work that's gone on in the industry for decades. Yeah, you guys. Go to hell. So, with that, like and subscribe if you enjoyed this, especially the end bit. Those are kind of the standards that are going on. I haven't talked about the other standards that we're involved in. We'll leave those as surprises for the people that I just mentioned, so that we can go out there and they either have to meet or go away. Or if they bugger up the industry, well, guess what happens with standards if you're not meeting them and you bugger up somebody's place? Yep. Makes it a lot easier when an expert's brought in when they come after you. And I'll just leave it at that, because I'm waiting to watch that start to happen. It should. So like and subscribe. Have a great day. Have a great weekend. Next week, I'm going to have something a little bit lighter. I'm trying to get an interview set up with some people. If not, we'll have some other stuff going on, probably in relation to a field project that we have going on this upcoming week that should be very interesting, because it was an AI recommendation that should never have happened, and a vendor recommendation that I suspect they're going to pursue as we try to correct the first one to show them that they should never have made that decision. And here's how it's supposed to work from the actual manual and, 100 years worth of history. So in any case, with that, have a great day. I'm out. Have a good weekend.